Good day everyone. Welcome to another video on this lecture series related to machine learning. So in this particular video lecture, we will start the discussion about the supervised learning. Basically, our aim in machine learning is to learn the data, or we can say learn the patterns in the data, and then after learning the data we will predict output of some unknown data. Okay, so we have to first learn the data, or we can say the system that we are developing, we have to train that particular system. After training the system, we will use that trained system to predict output of some unknown data. Now you can see that for learning, or we can say for training a system, we need a data. Okay, there should be some ready-made data available with us. So we have a training data, or we can say this is our experience from which we want to train our system, or we can say we want to make our system intelligent. Now in supervised learning, this particular data, or we can say this particular data set, it includes the data points which have both input as well as output. Okay, so in supervised learning, we are training the system using a data, and that particular data set has both input and an associated output. Okay, and in this particular data set there can be m number of data points. What does that mean, m number of data points? It means that let's say we have one type of input 1, and for that we have output 1. Then we have another type of data, input 2 and output 2. Okay, so these are in pairs, and the set of these, so these can be m such pairs, input m, and we have output m for this particular input. Okay, and this data combination is our data set. Let's take an example. For example, if we want to train our system, so we want to design a system, and that particular system should predict the price of a house. Okay, we want to design a system, and that particular machine learning system should predict the price of a house. What should be the price of the house? Before using this particular system to predict the price of a house, we have to train this system. Okay, and if we are using supervised learning, to train this particular system, then for training we need a data set, and that particular data set should contain various data points of this type. It should contain the known data, or we can say various types of houses. For example, the features of house 1 and its price. So this is the known, this is the input, and this is the output. This is one type of house. Likewise, we may have multiple such data points already available with us. So we have features of houses and their associated price. Then using this particular data set, we train this system. Okay. After training this particular system, so we have a trained system. So we have a system. So a system that has been trained on already known data. And what was the feature of this particular data? This data has both input and output. Okay. Now we will take this trained system. So this is the trained system. We will take this trained system and we will deploy it. Deploy it means that we will now use this particular system to predict the price of a house whose output is not known. So let's say we got some features of some unknown house. Unknown house here means we don't know the output of this house, or we can say the price of this house. Okay, so we will give this input to this system which has been trained on the known data, and it will give us the predicted output, or we can say predicted price. So we will say that this particular system has been trained using supervised learning. So this is the important concept in supervised learning. So what I am saying, that in supervised learning, we are training a system. We are training a system using a data, or we can say using a data set. And the features of this data set is that it will have multiple points, multiple data points which have been given input as well as output. So we will have m number of such data points. We know their input as well as output. After training the system, then we will deploy this particular system to predict the output of some unknown input. Okay, and here input is usually represented by x and output is represented by y. Okay, and you can see that this input depicts the features, or we can say these are also called parameters of a quantity. For example, as I give an example in predicting the price of house, the input can be the multiple features of an house. For example, the size of house, this is one type of feature. Another parameter or feature we will say is the number of bedrooms. This can also be another feature. Okay, another feature you can say the location. So these are the three features of a house. And what is the output? So output is only price. A single output is there. So we will say every input. So since we represent input by x, so let's say x1. If I am writing x1, it means the features of data point first. So what are its features? What is x1? X1 is size, number of bedrooms and location. So we write it like this: x1 1, means the first feature. What is the first feature? Size x1 2. It means the second feature of first example, or we can say first data point. And x1 3, it means the location of the first data point. So this is one example. Likewise, we will have multiple such data points. So let's suppose another data point will be like this: x21, x22, and x2. And if I have the ith data point, so what will be its different features? It will be xi1, xi2, and xi3. Okay, so this particular data set, so we can say that every data point, or we can say the inputs of every data point is a vector, row vector. Okay, which has how many rows, how many data points, or we can say how many columns. Columns are equal to number of features. So here you can see how many number of features we are using for the input: 3. And let's say if there are n features, then for every ith input, what will be the size, row size? So how many features are there? N. So the first will be this one, the second will be this one, up to x I n. This will be the nth feature. So we can say that every input feature is a 1 cross n input matrix. 1 cross n row vector. Okay, so here what we have learned so far. So we said that in supervised learning, our data set contains m examples. So we will say there are total m data points, m examples. Let's say the first example will be x1, y1. The second example will be x2, y2. And it will have total x m y. Fine. So this will be our data set. And how many examples are total? M examples. Now you can see that every input, so this is the input and this is our output. So ith example can be written as xi, comma yi. So for ith data point, xi is its input and yi it is output. So this xi, every xi, let's say every xi has n features. So we can write every xi like this: x1, xi1, xi2 dash 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 xi. So this 1 cross n row vector represents input of ith example, and these are its parameters: parameter 1, parameter 2, parameter n. Like we were using for every house: size, number of bedrooms, and the other feature was location. So there we were, for every example, there were how many input features? 3 features. So we can do like this. For example, we can combine all input features together to form a matrix. Okay, that is called input matrix X. that is denoted by capital X. So every X, so this X will contain all the inputs of this data set. So what are the inputs? X1 is one input, X2 is another, Xm is another. So I will write it in this particular format. So X1 will be the first row, X2 second row, dash dash dash. How many rows will be there? M rows. And if I expand it, we know that every this input is of how many features? N features. So this can be written as x11, x12 dash 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 x1n. Likewise, the second example can be written as x21, x22 up to x2n. And like so we will go, the last one will be xm1, xm2 dash dash xm. So this input matrix, it is also written as input matrix. So this input matrix will be of size m cross n. It is a matrix of size m cross n, and every row in this particular matrix represents the input. And likewise we will combine the output of every data point, and it will also be written like a vector y is equal to, the first one will be y1, the second will be y2 dash dash dash, the last will be ym. Okay, and we know that every y is an integer, or we can say it is a single dimensional entity. Okay, so this will be so since every y is a single dimension entity, so the size of this particular matrix, this y will be m cross 1. We will also say that it will be a column vector. You can see that every x is an n dimensional vector. N dimensional means that it has n different features, and our x is an m cross n feature matrix. Okay, so we have understood that in supervised learning what we are doing, we have a system. Okay, so in supervised learning we have a system. We train this system on a data set. So we have a known data set, but what is the important characteristic of this data set? The important characteristic of this data set is that it contains m data points, and every data point is of this particular format. So that means we are given both the input as well as the associated output, and every input is an n dimensional vector. So that means it has n features. So n can be anything, 1, 2, 3, 4, anything, and y is a single dimensional vector. So it is a single quantity. Okay, not a vector. We can also say that it is a simple number. And in this system, this data set can also be represented like this: X matrix. X contains inputs of the data set, and Y contains outputs of data set. So the first row of X will denote the features of first data point, and first number in y column, the first element in this y will be the output of first example. Okay, fine. So what I'm saying, we have a system, we train this system on a data set, and this is our data set. Now after training this system, we have a trained system. We deploy this system. Deploy means now if I am given an input x, okay, and this x is unknown. Unknown means that I don't know the output y. Okay, so here in the data points of the data set, we know both the input as well as output. However, if now there comes some input whose output is not known, we give this input to the trained system, and this trained system gives us predicted output. Predicted output is also written y hat. Y means actual. If I write y, it means actual output, and y hat means predicted output. And our aim is that we have to train our system in such a way that our predicted output is same as actual output. This is our aim. Our predicted output should be equal to the actual output. Now we want to see how we can train our system. Basically, when we are saying that a system is trained on a data set, what this system is doing is that in supervised learning is that it tries to find a relationship between input features and output of the data set. Okay, so since it has the data set, it will try to find the relationship between the input and the output. After finding the relationship, so it find input output relationship. Okay, then after finding this relationship, if we have now unknown data and we already know how it will be related to the output based on this relationship, we will use this relationship and this particular data, we will combine these together and we will get the predicted output. Now what can be this relationship? So we can say this relationship will be like an equation, some equation, mathematical equation, where our output will be equal to some function of input. Okay, so here relationship is that this particular function. So that means when we are training our system, we are trying to find this particular relationship, or we can say find this particular function that maps input and output together. Okay, but you have to keep in mind that it is not possible always to find a function that correctly maps input to the output. So we will try to find a function that is approximate that, or we can say that approximates the output and input. Okay, not an actual function, not a function that will give the correct result always, but we want to have a function that relates these two as much closely as possible. Okay, so this particular function that we are trying to find, that captures the relationship between the input and the output, this particular function, or there can be multiple such functions, the class of such functions is called a hypothesis class. Or we can say, let me repeat it again. So we have a data set whose input is also given and output is also given. Now training here means that we want to find a function, okay, that captures the relationship between input and output in the data set. So that means if we are able to find this function, then we can use this function to give then output on an unknown input. Okay. Now to assume this particular function, so this function can be anything. Okay, it can be a linear function, non-linear function, exponentiation, anything. Okay, so we can say that we have to assume this function initially. So what I mean to say, for example, if I visually saw this particular data which is known to me, input output data, if I am able to find that there is some sort of linear relationship between the input data and the output data, then I will assume that this particular function will be linear. What I am saying that I already have a data set, so that means I can visually see, I can plot this input and output. I will see that there is some sort of linear relationship, but now I don't know what kind of linear relationship. But yes, I can assume that there is a linear relationship. So that means this function will be a linear function. Okay, so in data science, or we can say in machine learning, you always have to make some assumptions. Okay, but those assumptions should be very related to the relationship between the input and output. You cannot make any random assumption. Okay, it should be a valid assumption. So we assume, let's say it is a linear relationship between an input and output. So that means the function that we are trying to find, it will be a linear function. But there are n number of linear functions. There can be different type of linear functions. So from this class of linear functions, we have to find a linear function that will closely capture the relationship between input and output. So this n number of linear relationships is also called a hypothesis class. So we have a hypothesis class. What does that mean? What that means is that we said that the relationship between the input and output is a linear relationship, but this linear relationship can be anything. N number of linear functions are possible. So the set of all those functions is called a hypothesis class. But from this hypothesis class, we have to find only one function. So this is also represented by capital H. So from this hypothesis class, we have to find one hypothesis function that should closely capture the input and output relationship. Now, how will you choose this particular hypothesis function, or we can say, how will you say that which function is best? So what we can do is that with every function we will associate a loss. So what is this loss? I will say. And then we will see from this particular loss, we will find the loss of all the functions. Linear functions. Why linear functions? Because we assume the relationship is linear. Okay. So we will find the loss of all the functions. Then from these functions, we will choose a hypothesis that has the minimum loss. That will be our final hypothesis function, or we can say that will be the function that will closely capture the relationship between input and output in the data set. Okay, now let's see what is this loss. Okay, we want to find a hypothesis function, and this hypothesis function may be any function in this hypothesis class, okay, so let's see what is this loss function. So we can define loss in different ways. So this loss, or I can also denote it with L. There can be different ways of denoting a loss. Now let's say we have a hypothesis class. Hypothesis class contains multiple linear functions, hypothesis functions. Let's suppose we first choose h1 as the function. We will find the loss of this function. Loss here means, so one type of loss is also called 0-1 loss. What is this 0-1 loss? It means that we will use this function h1. Now we already know we have a data set, and this data set contains x1, y1, dash dash dash, xm, ym. Fine. So this is our training data set. We have this hypothesis function. To this hypothesis function, we will give x1 as input, and we will get the output, predicted output for first example. Then we will compare this predicted output with the actual output, this y1 with the actual. We will do the comparison. If they are equal, then to the total loss we will add 0. However, if they are unequal means that they don't match. We want that they should always match. This function, when we give an input, it will give the correct output. But if they are not matching, then we will say there is loss equal to 1. So this is also called a 0-1 loss. So let's suppose if the loss is equal to 20. So what does it mean? It means that out of m examples, 20 are mispredicted. Or we also say that training loss or training error is 20. But why training loss or training error? Because we are checking on the training data set. That is why it is also called a training loss or training error. The error that comes on the training data is called a training loss. So h1 is giving this loss. Now similarly we will calculate for h2, we will calculate for hn. Okay, by calculating for all the hypothesis functions, finally we will choose that particular hypothesis function that minimizes the loss, that has minimum loss. Okay, or we can also say that has minimum summation loss h comma x comma y for all h that belongs to hypothesis function. So for every hypothesis function we will calculate its loss. Here summation means that first we will calculate for first example, then for second example, and we sum them. Whichever gives the minimum loss, whichever hypothesis function gives the minimum loss, that is chosen as the final hypothesis function. Okay, so this is one kind of loss, but this particular loss is very rarely used. Okay, why rarely used? It is because let's suppose we are predicting the price of a house. So for predicting a price of a house, let's suppose I have predicted the price is $5,000, let's say, and the actual is, let's suppose, 5,001. You will see that this our prediction is close to the actual, but in 0 1 loss it will calculate this as loss equal to 1. So it will say that this is a completely misprediction. Okay, but you can see that this is very closely related to each other and we should accept it as right prediction. Okay, so that is why 0 1 loss is not always used. So there is another loss that is most commonly and most frequently used, that is the root mean square loss, or mean square error. Root mean square error. So what we are going to do, we will first calculate, so like the similar way we will take h1. Okay, so we have a hypothesis function, we will have input, okay, for x1, and we will get predicted output. So this is our prediction, or we can say h1 x1 is our prediction. But what was the actual value? The actual value was y1. Okay, we will calculate this. Similarly, we will calculate for x2, and this is our actual. Likewise for x3 m. Okay, so this is our prediction and this is the actual. Then we will calculate their difference. So we will sum their differences. Sum of h1 xi minus yi whole square for our I running from 1 to m. So we will find the difference of these two and then we will square it. So this is also an error. Root mean square error. So that is why it is called a RMSE loss. So this is the loss of h1 function on input x and output y. So this is the total loss, h1 xi minus yi. Similarly, we will calculate this particular loss for h2 function, for h3 function, for hn function, and the function that gives the minimum loss, that will be taken as the final hypothesis function. And this particular loss we will be using more frequently. Okay, so I hope you understood the main nature of training, how we train our system. Okay, machine learning system. Now you will see that you saw that in supervised learning we have a data set, and this data set has input and associated output, and we considered how many examples? M examples. And as I said that this data set can also be represented with the help of two matrices X. So each row of X is one data point. Okay, and the size of this X is m cross n, where m is the number of examples, number of data points, n is the number of features in each data point, and another matrix is y. So y contains the output of these points. It is 1 cross m. Now in supervised learning, if if the output of the data set is discrete. Discrete means that these are fixed numbers. For example, let's say if I have a data set of diabetic patients. Then for every example, you will see what will be the input. Input will be the feature of diabetic patients. For example, what is the weight of the patient, what is the age of the patient, or some other features. What is the color of hairs, what other things, what is the height of the patient. And output can only be 0 or 1. 0 or 1 means diabetic or non-diabetic. Okay, so you can see that this kind of problem where we want to learn a relationship from the input to an output, but the output is discrete, 0 or 1, or it can be 0, 1, 2, 3, let's say like this. Then this kind of problem is called a classification problem. Okay, however, if the output is continuous, for example, in case of predicting the house of a price, so the output can be anything. Okay, so in that particular scenario, the problem is also called a regression problem. Okay, so in the next lecture, we will first start with the regression problem, where we will see how we can learn a hypothesis, or we can see how we can choose a hypothesis function. I have already discussed how it is chosen, but we will see with an example here. So we will first see the regression problem, okay, and the algorithms, ML algorithms for regression problem. Then after that, we will see some classification problems and ML techniques for classification problems. So before wrapping up this particular video, so you have to understand what we discussed. We discussed what is supervised learning, okay, and what is a data set in supervised learning, what is a hypothesis class, and how we choose a hypothesis function. Okay, and in this hypothesis function, we saw two types of errors, two types of losses. One is 0-1 loss, and another is root mean square error, but this one is more frequently used. Then we saw that in supervised learning, the data set, it can be written in the matrix format X and Y. Okay, also we saw what is a classification problem and what is a regression problem. So in the next lecture, we will start with the regression problem, and we will see how we can design a machine learning for that particular problem. So basically, we will be discussing about the linear regression algorithm. Okay, so let's meet in the next lecture, where we will be discussing about the linear regression algorithm. Till then, goodbye.